Space debris, managing the growing threat in orbit. Title: Space debris, managing the growing threat in orbit. Introduction. As humanity continues to explore the vastness of space, we have inadvertently left an ever-growing trail of debris in our wake. Space debris, also known as space junk, refers to defunct human-made objects that are floating in space, posing a significant threat to satellites, spacecraft, and even astronauts. With the increasing number of satellites being launched and the lack of a proper waste management system in place, space debris has become a critical concern. In this article, we will delve into the challenges posed by space debris and explore potential solutions to mitigate the growing threat in orbit. The threat of space debris. Space debris encompasses a multitude of objects, including spent rocket stages, defunct satellites, fragments from collisions or explosions, and even tiny pieces of paint. While space is vast, the amount of debris is reaching alarming levels. Currently, there are estimated to be over 128 million objects larger than a millimeter in orbit around Earth, with only a fraction of them being actively tracked. The danger posed by space debris lies in its high velocities. Even small fragments can cause significant damage when they collide with functioning satellites or manned spacecraft. Hypervelocity impacts can create a cascade effect where collisions generate more debris, causing a domino effect that heightens the risks for all orbiting assets. This phenomenon, known as the Kessler syndrome, could eventually render certain orbital regions too hazardous to navigate. Challenges in managing space debris. Managing the growing threat of space debris presents several challenges. Firstly, tracking and monitoring the debris is a complex task. While larger objects can be detected and monitored by ground-based radars and telescopes, smaller debris remains harder to track due to their size and erratic trajectories. Additionally, accurately predicting the behavior of space debris is highly challenging, making collision avoidance maneuvers a difficult task. Furthermore, the responsible utilization and disposal of satellites and rockets are crucial. Currently, there is no universally adopted set of guidelines or regulations for satellite operators and manufacturers to follow regarding end-of-life disposal. As a result, many satellites, once they have exhausted their useful life, remain in orbit as potential debris, adding to the growing problem. Potential solutions. Addressing the issue of space debris requires a multi-pronged approach involving technological advancements, policy changes, and international cooperation. Here are some potential solutions to manage the growing threat in orbit. 1. Active debris removal, ADR. One of the most promising solutions is the development of ADR technologies. These techniques involve capturing, redirecting, and removing space debris from orbit. Concepts include using robotic arms or nets to retrieve debris or deploying sails to slow down and deorbit defunct satellites. Designing satellites to burn up upon re-entry or self-disassembly into smaller, harmless fragments can significantly reduce the long-term buildup of space debris. 3. Improved tracking and monitoring. Investing in advanced tracking technologies and expanding the global network of space surveillance radars and telescopes is crucial. Improved tracking capabilities will allow for more accurate predictions of potential collisions, enabling timely avoidance maneuvers by operational satellites and spacecraft. 5. Space traffic management. Similar to air traffic control systems, space traffic management frameworks can be established to coordinate the movement and behavior of satellites and spacecraft. This centralized approach would enable collision avoidance maneuvers, regulate satellite launches, and ensure adherence to space debris mitigation practices. Space debris, managing the growing threat in orbit. Introduction. As humanity continues to explore space, we have unintentionally left behind an increasing amount of debris. Space debris, or space junk, refers to defunct human-made objects floating in space, posing a threat to satellites, spacecraft, and astronauts. With the number of satellites being launched and the absence of proper waste management, space debris has become a significant concern. In this article, we will explore the challenges posed by space debris and potential solutions to mitigate the threat in orbit. The threat of space debris. Space debris includes spent rocket stages, defunct satellites, fragments from collisions or explosions, and tiny pieces of paint. While space is vast, the amount of debris is reaching alarming levels. Currently, there are over 128 million objects larger than a millimeter orbiting Earth, with only a fraction of them being tracked. The danger lies in the high velocities of space debris. Even small fragments can cause significant damage when they collide with functioning satellites or spacecraft. These impacts can generate more debris, leading to a domino effect and increased risks for all assets in orbit. This phenomenon, known as the Kessler syndrome, could make certain orbital regions hazardous. Challenges in managing space debris. Managing space debris presents several challenges. Tracking and monitoring the debris is complex. While larger objects can be detected with ground-based radars and telescopes, smaller debris is harder to track due to size and erratic trajectories. Accurately predicting debris behavior makes collision avoidance maneuvers difficult. Furthermore, responsible utilization and disposal of satellites and rockets are crucial. Currently, there are no universally adopted guidelines or regulations for satellite operators and manufacturers regarding end-of-life disposal. This results in many satellites remaining in orbit as potential debris. Potential solutions. Addressing space debris requires technological advancements, policy changes, and international cooperation. Here are potential solutions to manage the threat in orbit. 1. Active debris removal, ADR. ADR technologies involve capturing and removing space debris from orbit.